This video is on the normal distribution. The topics to talk about are the standard normal distribution and the general normal distribution. The normal distribution you're used to seeing as the bell curve. So let's take a look at the normal distribution and let's look at some of the probabilities in between values of z. So for the standard normal distribution, by standard, what we mean is that the mean, or the average, is equal to 0. And the standard deviation is equal to 1. Those are the easiest numbers you can imagine for the mean and the standard deviation where it's still relevant. Since it's a normal distribution, what that means is it has a shape of a bell curve. So it starts low, it goes on up, and it peaks right in the center, and then it comes on and goes down low. Notice it is symmetric about the mean, and because it's a standard normal distribution, it's symmetric about the mean of 0. And then what we can say is that about 68% of the data is between -1 and 1 for the value. We're going to use the letter z for that value. So in between z equals -1 and z equals 1, that area is 0.68, or we can think of it as 68% of the total area. 95% of the data is between -2 and 2. So if we go from a z equals -2 to z equals 2, then that area will comprise of 95% of the total area, or the probability of being between -2 and 2 is 0.95. And then finally, 99.7% of the data is between -3 and 3. So if we go from z from -3 to 3, then that will cover approximately 95% of the total area under this curve. So that is the normal distribution. It is used in many, many, many places. You've probably seen it at the beach. If you drop sand, then it kind of looks like that. It kind of looks like a bell curve in a way. But more importantly for statistics, we're going to be using the normal distribution for looking at outcomes of surveys. And that will happen not in this chapter, but in chapters that come a bit later. So now let's take a look at some example problems where we have to find probabilities, or given a probability, find the values. So let's take a look at the following. If z follows the standard normal distribution, the first question is find the probability that z is between -3 and 3. The second question is find the probability that z is less than 1. And the third question is find the probability that z is greater than 2. So let's start on the first question. We want the probability that z is between -3 and 3. So if we go to our diagram, z between -3 and 3, well, that's easy. It just shows you that is 99.7% of the data. So the probability that z is between -3 and 3 is 0.997. For the second question, we want to find the probability that z is greater than 2. That's a little bit harder because we need z to be bigger than 2, which is this little area over here. So to find that little area over there, what we can say is that if we take this area here past 2 and add in the area over here to the left of -2, those two combined will be the complement of what's between -2 and 2, We know between -2 and 2 is 0.95. So the complement will be 1 minus that. But we don't want both of these, we only want one. But by symmetry, one of them is half of both of them. So I can put what I just said together and say I'm going to take 0.95, subtract that from 1 to get the outside, and then divide by 2 or multiply by a half to get just the right-hand side. So the probability that z is greater than 2 is 1/2 times 1 minus 0.95. And that little arithmetic, that's equal to 0.025. The third question is to find the probability that z is less than 1. So now that's all of this area over here. So everything to the left of 1. And I need to find that probability. So to do that, it's kind of similar to the last one. What I can do is first take this piece between -1 and 1, and that's 0.68. That's this kind of yellow area over here in between -1 and 1. And then I have to add in what is to the left of -1. And that's real similar to what I just did, because the left of -1 times 2 will be the outside area. Well, the inside area is 68%. So the outside area is 1 minus 68%, or 32%. So I can say that if I combine this left and the right, I get 0.32. Half of that will give me just the left. So I take the 0.68, this middle area, plus this 1/2 times 0.32, this left area, and that gives me my total area to the left of 1. So 0.68 plus 1/2 times 0.32, I popped that in my calculator, and I got 0.84. So there's the three answers to finding probabilities when we're given a standard normal distribution. Now let's talk about other kind of probabilities. If we're not so lucky and we don't have necessarily -3 to 3, if we don't have a standard normal distribution, there's more work to do, kind of. So first thing is, if you don't have a standard normal distribution, you can always turn it into a standard normal distribution by converting to a z-score. So remember, the z-score is z equals x minus mu over sigma, or the value minus the mean, all divided by the standard deviation. And the z-score tells us how many standard deviations away from the mean the value of x is. Okay, it also converts from a general normal distribution to a standard normal distribution. So you can always do that if you need to. But there's actually an easier way in the real world, and that's called calculators. So we'll see how to work those out. So let's take a look at an example. IQ scores are normally distributed with mean 100 and standard deviation 10. The first question is, find the probability that a randomly selected person will have an IQ score between 80 and 120. There's actually a couple ways of doing it. Let's do the way with the calculator first. So here's the calculator, and I need to scroll down a bit. And I'm going to go to number 8, which says normal probability. And it asks for the low, the high, the mean, the standard deviation, and the probability. And it says fill in all the values except 1 and hit calculate, and then the last value will be given to you. So in particular, we wanted to find the probability that it was between 80 and 120. So the low is 80, the high is 120, and then the mean was 100, that was given, and the standard deviation was 10. And I leave this probability part blank. And that's it, I hit calculate. And I get about 0.95-ish, about 0.95. So now I can go back and review the question. Okay, so we got 0.95 approximately for the IQ score between 80 and 120. Now it's interesting, this one we could have done it a different way if we wanted to. So notice that 80 is 2 standard deviations below 100, and 120 is 2 standard deviations above 100. So in between z equals -2 and z equals 2 is 95%. And there we have it. So now let's look at the next question, which says, find the probability that a randomly selected person will have an IQ score greater than 110. So let's go ahead and go back to the calculator. So here's a calculator where I left off again, and the mean was 100, standard deviation was 10. We don't know the probability. I'm going to leave that one blank. We want to be greater than 110. So the lowest value that could be greater than 110 is basically 110.00000 zillion zeros and a 1. So I'm just going to call this 110. And you can do that with continuous distributions. If we want greater than a certain number, you can just use that number. With discrete distributions, then you have to like edge it up a little bit. But with continuous distributions, and the normal distribution is continuous, we don't have to edge it up. Well, if we want to be greater than 110, then the highest IQ score that's greater than 110 can be unlimitedly high. It's infinity. So I'm going to trick my calculator, and this is what you're going to want to do, is I'm going to put in a bunch of 9s, and you always want to put in at least 2 more 9s than the number of digits that we see in any of these numbers. And I see 3 digits, so I put in 5 9s, and that should be fine. And then I hit calculate. And there we go. I'm going to round it a couple decimals, and I get 16%, or about 0.16. So let's go back to the question. All right, so we got 0.16 for the probability of being greater than 110. Note, by the way, we could have done it by saying 110 is 1 standard deviation above 100, and we could have found how if you have a z-score greater than 1, then the probability of a z-score greater than 1, we can do what we did before, and we would have gotten about 16%. But I did it with a calculator. Okay, now let's do a third one, and that is, what IQ score must a person have to be in the bottom 2.5 percentile? So you say, what's the highest IQ score to be in that 2.5 percentile is another way of saying it. So let's go back to the calculator. We want the 2.5 percentile. Okay, so here's the calculator again. We have the same mean, the same standard deviation, but now we want the 2.5 percentile, and that means the area to the left is 0.025, or the probability of being to the left of a certain number is 0.025. So this time I know the p. So I'll put 0.025 in for p. We want to find out the value such that to the left of that value has this probability. So in particular, we don't know the value, and that's the high. Lowest is basically negative 1,000,000 or something like that. I'm going to write negative 99999, bunch of 9s, always at least 2 more than the number of digits, so I did more than that. And I hit calculate. And there we go. To round it to the nearest whole number, that's an 80 IQ score. So now we can answer the question. And we can say that if you have an IQ score of 80, then you're in the bottom 2.5 percentile for IQ. Okay, we also could have done this with a z-score because notice 2.5%, double that is 5%, 1 minus 5% is 95%, and then go from there because we know about 95% corresponds to a z of 2, and then 2 standard deviations to the left of 100 is 80. That's the other way of doing the same thing. So let's do the next problem. So suppose the mean class size at college is 22 students, and the standard deviation is 5 students. Assume the distribution is normal. Find the probability that a randomly selected class has, part A, fewer than 15 students. So very similar to the last question, where we have a mean, we have a standard deviation, and we want to find a probability. Now it's fewer than 15, mean 22, standard deviation 5. So now we can go to our calculator. So here's the calculator again. I'm going to hit refresh, and that way I start over with new numbers. I could also go back to the calculator menu and then go to the normal probability. But instead I hit refresh. So now I want to find out the probability that it's less than 15. So the high will be 15. Anything bigger than 15 is too high. The smallest that you could be less than 15, well, that's negative infinity or negative a bunch of nines. And we were given the mean, 22. And we were given the standard deviation, which was 5. And I want to find out the probability. So I just hit calculate, and that's all there is to it. And it looks like it's about 8% or so. So let's go back to the question. All right, so here it is. The probability of being fewer than 15 was 8%, or about 0.0808 if you looked at the numbers. So notice that one we could not have done just by using a z-score, because 15 does not have a nice z-score when we're talking about a mean of 22 and a standard deviation of 5. So there's no choice. You have to go and use the calculator for this. So let's do another question. How about what is the probability of having the class have more than 19 students? So similar problem, I go to my calculator and I need to find the probability of greater than 19. So here's the calculator again. We still have the same mean and same standard deviation of 22 and 5. We don't know the probability, so I'm going to erase that. We want to be greater than 19, so that means the low is 19, and the high is just infinity, or a bunch of nines will be good enough to trick the calculator. And I hit calculate. And there we have, it's about 0.72574, dot, 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 dot. So it goes on and on. So we're able to answer the question now. That's as easy as this is. So the probability that a randomly selected class has more than 19 students is about 0.7257. And then finally, what's the probability that the class will have between 18 and 25 students? So similar, I go to my calculator. So here's my calculator. Same mean, same standard deviation. I want the probability, so I erase probability, or the P equals. And now the low, I want to be between 18 and 25. So the low is 18, and the high is 25. That's all there is to it. I hit calculate, and it gives me 0.513891, etc. So I can answer the question very easily now. So the probability that the class will have between 18 and 25 students is about 0.5139. So let's look at another example, and hopefully you're seeing that these examples are all pretty similar. Let's do another one. All right, so a manager at the market finds that the distribution of receipts at the market is normally distributed with mean $42.18 and standard deviation $17.65. find the interquartile range. So possibly the hardest part of this one is to remember what the IQR is. And what that is the range between Q1 and Q3. Remember, Q1 is the first quartile, or the 25th percentile, and Q3 is the third quartile, or the 75th percentile. So I need to find the 25th percentile and the 75th percentile. So I go to my calculator and I find those percentiles. Let's take a look. So here's my calculator. Let me just hit back to the calculator menu. And just to remind you, I'm going to scroll a little bit. And number 8 is normal probability. All right, I want the 25th percentile. So the 25th percentile means that the low is basically as far left as you can go. That's negative 99999. And then the high is what we want, so we leave that blank. The mean for this particular example is $42.18, so 42.18. And the standard deviation for this example is $17.65, so 17.65. And I want the 25th percentile, so that means that the probability of being under that number is 0.25. So P is now 0.25. And I hit calculate, and there it is, 30.275, etc., etc. So now I can go and take a look at that. Okay, so the first quartile is 30.28. Now I want the interquartile range, which is the third quartile minus the first quartile. So I need to find Q3, which is a 75th percentile, which means that I want to say that the probability of that value or below is 0.75. So let's go back to the calculator again. So here's our calculator. We want our probability to be 0.75. And in this case, the mean and standard deviations haven't changed. The low is still negative infinity or negative 99999. And the high is what we want because that will be our third quartile. And I hit calculate. And I get 54.0847, etc., or about 54.08. And now I can go work out the interquartile range by going back to the question. So we have that Q1 is 30.28 and Q3 is 54.08. The interquartile range is Q3 minus Q1. So I just subtract, and I find that the interquartile range is 54.08 minus 30.28, and that, I calculated out, was equal to 23.8. So I can say that the interquartile range for the receipts at this market is 23.8 or $23.80. And that's really the last type of question that I wanted to show you. We now know how to find probabilities that come from a normal distribution. We know how to find a value at which we're at most that or at least that if it comes from a normal distribution and if we're given the probability of that occurring. So that's all I have to say for normal distributions. If you have any questions, you can always ask me, or if you have another instructor, ask your other instructor, and we'll be happy to help. Thank you for watching this video.